Well, good morning out there, or good evening wherever you are in the world. Welcome to another edition of CGS Live, and this is the Houdini version, Houdini special. My name's Daniel Hourigan. I'm the head of effects at CG Spectrum, and yeah, this week I think I don't really have a plan this week. I'm not going to work on a project, I don't think, or a big project, or maybe I'll make one. Hey guys, hey Audrey, hey Michael. This week, I think I did have a bit of an idea just before while I was making my coffee, so I might try and do that. I was thinking like a kind of acid melting effect, where you have like a flip simulation or something. Yeah, chill week and then straight into acid melting. Yeah, I don't really want to jump into like a massive project. I really like all of the suggestions that are coming through at the moment. So we've got tons of cool suggestions. Someone just put one in the comments as well about a car crash, which would be cool. But yeah, I just want to kind of do a bit of freeform stuff this week and talk about different things. And if you guys have any questions, then feel free to ask. Let's jump in. I'm gonna switch. I'm using my old camera today, so hopefully it won't freeze. So the idea that I had was to take like a grid or some sort of asset and squirt some fluid at it, and then just try and get it to melt or do some kind of cool effect. I'm sure I've seen this in movies. You guys probably know better than I do, but I'm sure I've seen movies where some acid or some kind of goo from an alien has landed on some metal and it's melted through and done something interesting. But yeah, let's just start with something basic. So grid, and maybe let's see, what am I going to do? I'm going to create a flip sim, so I'm just going to do a little sphere here. And yeah, I'll just move it over like this. Just gonna squirt it out, and I'll run that into a points from volume. I'm still battling a cold. I apologize for any coughing in advance. So let's run this into a null, and I'll just say out flip source. There we go. And the grid's going to be our collision object. So I might, let's see, what I might do is do a poly extrude on this and then turn it into a volume. Now, ordinarily, if I was just doing a grid, I could just use a ground plane, but because I want to do something with this, now I'm putting a reverse down to flip that, because you can see when the poly extrude goes negative, it gives you reversed faces. So the windings of those polygons are inverted, so they show up blue. To get them to display correctly, you put a reverse down. Yeah, because this is going to be like a dynamic sort of effect, I'm not just going to use a grid. I'm setting this up with an idea in mind. So I'm going to do a VDB from polygons on that. I'm going to create those two things that are necessary for a good volume-based collision. So if I copy my null out, what is it, collision VDB, and plug that one into my reverse there. I'm also just going to, just to make sure, I'm just going to put down a facet and a trail with velocity. I may have mentioned this before, but when you have something that's static, even a static thing, putting a trail down or at least computing zero velocity is still good, because it does seem to create a nice sticky type effect with the collision. So that's always a good thing to do. Always good to make sure you have normals as well. So there's our source, there's our collider. Let's put down a dot network. And we need a flip object, a flip solver, and we're going to use a volume source to bring in those particles. Get rid of this default one that's on the flip object. Don't want that. Volume source. So we can just point this to that path out flip source. Particles, source particles. We don't have a group. Get rid of it. There we go. Static object. And merge our ground plane. How's everybody's weekends going? It's a long weekend here in Australia, but because we're kind of in lockdown, it doesn't really feel like it. Out collision geo, collisions, volume sample. Change that to collision VDB. Just check that. There we go. Cool. So we don't need to turn on use deforming, but well, not the entire of Australia, Michael. Just Victoria. Although, no, it's not bad. Like we have, I don't know. Actually, I don't know how many cases we have. 60 maybe in Victoria. No, it's not that bad. But we're pretty aggressive about not having many cases, so they throw us into lockdown pretty quickly. This last one was only for 2 weeks, so it hasn't been that bad. Oh, that's good. How many cases do you have in Chicago? It's kind of just become normal now, this whole thing. Let's put a gravity node down as well. And get this to... You're still in lockdown, Audrey. How long have you been in lockdown? Chicago's like, we don't care. Back to normal. Let's go guides, particles. Change that visualization type. Alright, well that's not a bad looking splash. Yeah, I mean, yeah. It's been good here for a long time, but as soon as we started bringing people back from overseas, that's when the cases started again, obviously. I'm just going to center this. Wow, since April. Oh, I guess that's not... Yeah, it's not too bad, but yeah, it's June now, so that's a couple of months. That sucks. Taking the Australia approach. Or the Victoria approach, I should say. Not all of Australia has had to lock down like we have in Victoria. But it's not so bad. Lots more time for Houdini, hey? Alright, so that's kind of a good starting point. Surprising that the sim looks quite nice. Now, let's think about what we could do with this in terms of the melting effect. Like if this is acid, let's say. I think what I'll probably do is make it goopy. So I'm going to enable viscosity. Don't know if I'll do viscosity by attribute. I might just do it on the particle tab here. Viscosity. And let's set that to 10. There we go. It's a bit goopier and a bit more alien acid-like. And maybe it's just kind of like one little blob. So we could go like, I don't know, let's do activation $F less than 24. So it just emits for 24 frames and then drops. Okay, so you can imagine, this in a movie where you've got some goopy stuff falling down and then maybe over time it starts to kind of bubble or, do something to the bit of metal or whatever it is. So now what we need to do is kind of look at how we could affect this static object. And the first thing that comes to mind is to sort of bring the flip out and create this kind of cyclical sort of thing where we bring the flip out. So .NET, flip object, presets, flip fluid. So there's our flip. And we transfer that information back over to the grid. So it kind of creates this loop where the grid is feeding into the .NET, we're bringing the .NET out, and then so we're dynamically affecting the grid. So let's actually move this. We'll move this down here. And perhaps I will remesh this to give it more uniform triangular mesh, but also a much denser mesh, so that we can do some interesting effects. And then I'm going to attribute transfer. Maybe just color. So let's go red. I swear, like 90% of the things that I do in Houdini involve the transferring of color in some fashion. It is the best way to get, you know, information from one thing onto the next. So you can see when I play this now, we get this kind of transfer thing happening. So we've got our fluid coming down. Oh, looks like we broke our collision somehow. I guess what? Why is it erroring? Oh, you know what? It must be erroring because of it must be erroring because of a loop, perhaps. I didn't think that would cause too much of a problem. Maybe I just need to come inside here and hit play again. There we go. So, I don't know. There must have been an error inside the .NET. But now we should be able to see. Yeah, I mean, this is the problem with doing these cyclical things. Sometimes they don't work because, like, it's created a dependency loop where, you know, this grid is dependent on this .NET. So perhaps instead of this, we could try and do it inside the .NET itself using a SOP solver. So let's try that. So instead of using, I mean, we could start with a static object, but maybe let's just bring in a SOP solver and try and do this inside. So merge. SOP solver will merge in the particles. So you can see there. So if I play this for a little bit, you'll see inside the SOP solver is my particles. So that's cool. Now, what we could do is have a SOP solver that doesn't run over data name geometry, but it runs over data name collision. It might need to be a capital C. Let's have a look. Yep. Let's jump back. Collision. So we should get in here, in theory. Let's hit play. Oh, let me simulate this for a bit. It might actually be called collision geometry. I can check. So yeah, that's bringing in nothing. So let's check. Geometry spreadsheet. Flip object. Geometry. Collision. Collision is the name of the field. Geometry here. Collision, there. So this is the one that contains the collision field, I believe. I think it's that one. So this one, we should be able to affect. We should be able to bring it in, just like we are the geometry one. If you put down a SOP solver by default, it's affecting the geometry data name. This one, we want to affect the collision. But yeah, it's, I don't know, maybe it's plugged into the wrong spot. Let's try plugging it into volume velocity instead. Back out. It's been a little while since I've done this. Let's see, hit play. Go inside. Yeah, we're not getting anything. So let's have a look at why that might be. Fetch geometry from .network. The data path is collision. What I would expect to see is some sort of field in here. So a collision field. So I'm obviously not doing it correctly. Let's plug. I'm pretty sure I can just plug it back in here. Let's try this collision geometry. See if that gives me anything. Oop. Nothing. Ah, it's annoying. Let's try this again. So what I'm checking here is when I middle click on this, I'm getting 0 points, primitives, and vertices. So, yeah, I'm getting nothing. Now, I'm pretty sure it should be collision because it should correspond exactly to this, this guy here. Oh, look, now it says collision geometry. Oh, so it looks like that's actually just what I've created. So I'm just fooling myself there. So we've got colliders. We've got collision. So we've got a collision field. Oh, maybe, yeah, maybe I'm just doing this wrong. Maybe I'm thinking about it the wrong way. So in Vellum, you do this. You do collision geometry, and maybe in RBDs, I can't remember, but I don't think so. But with this one, maybe actually what I should be doing here is just bringing in, using a DOP import. So DOP import fields. I'm going to DOP import from the DOP network the same way. So like .net /./, and then DOP node would be flip object. So we can pick it as well if we don't really know how to type that. So .net flip object. It's giving me a kind of complete path, but that's okay. So I'm going to choose flip fluid, but you can see now I'm getting geometry, surface, and velocity fields, but I actually just want the collision field here. So then I should be able to see, hopefully, if I hit play. Let's see, jump out. I get nothing. And you know why I get nothing? Because this is running over geometry. So let's run this over collision and see if that does anything. There we go. So it's working at least. And now inside of here, I should see on this the collision field. And I don't. So I guess maybe it's a lowercase c. It's always fun, trying to figure that stuff out. Oh, look, collision. There we go. So I wonder, actually, if I just did this, whether that would work. Ah, there you go. So I was just getting it wrong by not the old capital C. All right, so let's hit play, see what happens. There we go. So in here, here's my collision field. You can't see anything in the viewport, which is kind of annoying unless I go wireframe, but what you can do here is put a primitive node down and go to volumes, adjust visualization, and set it to something. So it should show something. Well, there we go. So now we can kind of see where that collision exists. Just makes it slightly more useful. Now that we've got that working, sorry it took me so long. It's been ages since I've attempted this, but I guess it makes sense because there's the name of the field. It is a lowercase c, so I should have just done that from the start. But I didn't think that would work, just bringing a field in like this. But essentially this is just a DOP import, so it kind of makes sense. Because whatever you write out here gets put in this slot here. So yeah, anyway, got it working. So now that we're kind of affecting the collision field inside this SOP solver, what we could do is also DOP import the fluid. So let's just do DOP import fields for this one, and go /// flip object. There we go. Choose flip fluid. So now we also get our particles in here, and let's also object merge our collision geo. So there's our collision geo. Now we can do our attribute transfer stuff, and it won't be like a cyclical loop because it's kind of happening inside the flip solver, and it's something we can easily turn on and off, and it doesn't affect our original collision geometry. So I'm going to do an attribute color. Whoops. Color. So back to where we started. So red. Attribute transfer CD. Okay. So nothing is really happening inside this node at the moment. We're just transferring some color to some geometry. This node is all about creating collisions, or bringing in the collision geometry and manipulating it. So let's see what happens if I was to create a VDB from polygons. Maybe, yeah, I'll just do it off to the side here. I'll call this collision. I actually think this needs to be a Houdini volume. You can see there it's a volume, not a VDB. So, and you could make it a fog or something. Let's see if it displays with a black background. Yeah, it doesn't really display. So we need to convert this as well. So we'll put a convert VDB down and convert it to a Houdini volume. There we go. So now we've got a volume. And what I'm thinking with this is that we could take this red transfer section here, maybe scatter some points onto it. So actually what I'll do is scatter points before, and I'll just copy the color onto the points so that I have a whole bunch of points across this surface, transferring color onto them like that. And then maybe I'll copy, oh, actually I'll just do VDB from particles on that. And that will allow me to copy these kind of spheres of volume around each point. But I'm going to set, based on that red color, I'm going to say at pscale equals at CD. And that will just give me 0 where they're black and 1 where they're kind of red. Now, if I use that and this, let's do a VDB combine and set it to SDF intersection, or maybe SDF difference. Oh, there we go. So you can see now this is eroding my object. Then I convert it to a volume. And this volume is called collision, so I'm just going to leave this as my last output and see what happens. And I'm going to disable my static object. Let's see if we still get a collision, or whether it just goes all the way through. So it's falling all the way through. Let's turn on our collision visualizer and see why. So collision. Ah, and that doesn't look right. So this is showing up that we have collision everywhere. And I think probably what might be the cause is this, that it's an SDF, not like a fog. So let's try changing this from distance VDB to fog. This one too. Call them both collision. The VDB combine should still, oh actually the VDB combine doesn't work on SDF difference. So we'll do subtract. And you can see there, hopefully we'll see some kind of subtraction going on. The top solver doesn't really play back correctly when you're inside here, but hopefully that'll do something. Let's see what happens. Hit play and see our collision guide has fixed. Oh, and there we go. So it's kind of weird. There's something odd going on there, but it's also kind of doing something. So that's kind of cool. Now let's go and have a look at why it's kind of a bit broken. So volume limits, let's just set these back down to something a bit more reasonable. 10, 10, 10. And I'll just select that and drag that up a little bit. There we go. Now when I hit spacebar G, I'm not zooming to a 50 by 50 bound so I can get to my object very quickly. Oops. Hey, Ivan, how's it going? Thanks for joining me. What time is it for you, Ivan? Is it late? Alright, so yeah, there's some weird stuff going on. Behavior of the particles is a bit kind of wacky shack. But 227, wow, nice. Thanks for staying up. But you know, you can see we're getting this like dynamic collision, which is interesting. It's weird that this is happening, where it's not flowing through that hole. I'm not really sure what's going on there, but I suspect actually what is going on is that when I look in here, this is not zero. Like, it's not perfectly black. There's a little bit of white in there. So let me make these slightly bigger and see if that helps. Now the other thing that I'm going to do is put a time shift in here. And I'm going to time shift back 10 frames. And what that I'm hoping will do is offset when this melting effect starts by 10 frames. Let's see. Let's see what happens. Straight through. Wow, weird. I mean, these are the weird things that you can get when you start really messing with this stuff, because I'm now just kind of making up my own collisions. I'm going to try plugging it into this input instead, the sourcing or post-solve input, and see if it makes any difference to the behavior. And it doesn't. It goes straight through. Nice. All right, so let's try something else. What I'm going to do here as well is let's convert over here to VDB fog to SDF. So there's our sign distance field again, and then we can do another convert VDB to polygons. So I'm going to try and use this as my static collider. Okay. I'm going to put a null down, and I'm going to say out dynamic surface. Put a facet and a trail. Trail might be a bit crazy because this is jumping around a lot, but let's see. So still going to leave my view flag here. And I just want to have a look at this one that's coming in again as well, and just kind of double check the information that's on there. Collision field. Yeah, it's a Houdini volume, and we're outputting collision, Houdini volume. Okay. Resolution, though, is something I just kind of chose voxel size of 0.1. Let's see what this one has. This one has a voxel size of 0.2 because it's being generated off the particle separation times the grid scale. So I guess I could do the same thing. I could copy this parameter, go inside the SOP solver, VDB voxel size pace relative reference, and multiply it by the grid scale. So the grid scale is there to make the volumes in Flip not be super ginormous. And then I'll reference this one because it means that you can take your particle separation down, but your grids don't go down by the same rate. They're sort of half as high res. So let's have a look at this. I can't see that one. Well, let's have a look. Let's see if that makes any difference, changing the resolutions to match. No difference. Fantastic. All right, so static object. Let's get rid of this. And in here, I'm going to point that to Slop Solver 2, out dynamic surface. And you can see it there. I'll turn on use deforming. Who knows what will happen here? Everything, the whole world might explode. Ah, look at that. We got a collision. That's good. Collision is good. But there's some weird stuff going on. This dynamic surface is not updating. For a start. Let's have a look at that. So let's turn this off. I mean, we could also point our volume resample to this as well, I suppose. Let's try that. Oops. Now, I don't think this will work like this because it's not an SDF. So let's, or it's not a, I mean, maybe, what could we do? Let's turn this off. Then it's a VDB. Does it work? Nope. So let's make it a SDF. So VDB, fog to SDF. Now it's a sign distance field. Looks a bit weird, like black, but I don't know. Let's see what happens. Collision guide. Yeah, it doesn't like that. Doesn't like that volume for some reason, and I don't know why. On the first frame there, we're getting a flicker. So broken. What have I done? Maybe I'll take this time shift off because that potentially could create some sort of weirdness. So, maybe that's why. So I'm going to blast because on the first frame, there's these fields in here which are showing up at world 0. So maybe they are causing a transfer to occur. So I'm just going to blast those. So at surface and vel. Change that to vel.star and it will delete all of those. And then hopefully that will have fixed that issue. Why is that erroring? I don't know. Alright. Let's see. Play. So it's going straight through again. So this is not working. Let's get rid of that. There we go. We get a collision this time. That's happening all the way up there. Let's set this to ray intersect and see, because this ray intersect will dynamically create a collision based on whatever geometry you feed it in here. So that could be interesting to try. So far it's not going so well. Straight through again. What a jerk. Alright. So, I don't know why this isn't working. Well, I mean, I do. It's because this is, you know, this is kind of mental, what I'm trying here. But, let's just try, actually. I'll turn this off. I'll set my particle separation to 0.05. Make sure my output is on the collision side. And I suppose the other thing that we could do here is we have our original collision here. We could add to that field so that we're, you know, we're always just, let's see, volume merge. So that we're always bringing in and outputting the field that came in originally. So just like you know, this is the original collision field that came in. So we're just adding to it with this new one that we've created. So we'll just set it to add. Let's see what happens. Nothing. Nice. So without the time shift, it does just fall straight through. So that is the issue. I'm gonna go back out here and see. I have a feeling that perhaps what I did wrong out here was not change the static object to be dynamic. So like I left this as not deforming. Maybe that's why it wasn't working. I'm just going to duplicate this one and see. It's possible that this just won't work and this is not, you know, the best approach, but I thought it could be an interesting thing to try. And that is, you know, that's the fun thing about Houdini, is you can just kind of try these things out, and if they don't work, it's okay, you know, it's a bit of time lost, but it's not the end of the world. So flip, well, .NET. Flip object, choose flip fluid, try again. All right, attribute transfer, color, poly extrude. All right, so I'm not doing anything apart from transferring color onto this collision geo now. So in theory, turn that one off. I've got use deforming. It's bringing in the VDB. So nothing's happening except for a little bit of color transfer, hopefully. Let's see what happens. There we go. So maybe that was the problem earlier, that I didn't have this flicked over to update using deforming geometry. So let's try with the SOP-based method instead, because the other method just seems a little bit tricky. Again, I'm getting this initial copy at the start. So what I'll do here is just bring out the geometry, and you can see that little dot goes away. So let's have a look now at this. So we could blast based on that color at CD .x greater than, I don't know, a number, just to see something points. So we should see as this solves. Let's do this out of the chain, because it does create that kind of loop if you're halfway through doing things and it might just error. Need my poly extrude back on. You can see all these errors down here. So it's definitely kind of a fiddly exercise. Hit play. Need to go back inside the .NET, looks like, and just reset this. Hit play. There we go. And, you know, this is all kind of trying to do it dynamically within the simulation. It's not necessarily kind of the only way to do it, but I think it creates an interesting sort of loop of things happening where you could drive this kind of erosion and then feed it back in as a collider so that you get this dynamic kind of erosion stuff happening. So let's do just a time shift again to offset this back in time. So $F minus 10, let's say. Like that. So now it's happening 10 frames later. And I'll feed that into my poly extrude now. And let's go inside here and see if everything breaks. Boom. But it worked. So there's an explosion, which, you know, it's not amazing, but we need to kind of work out, you know, what's going on there. Oh, and look, that's something that I didn't expect, where because the particles are flying everywhere, as those ones that sort of pass close to the geometry, they go through it, they start to erode that geometry. Now at the moment, what you can see is that this stuff is flickering. It's like, you know, as that particle goes through, it transfers, but as it continues to move, it doesn't. So that hole closes over. So we actually need to run that effect in a solver. So this attribute transfer, which is not happening in the solver, which is why it is easier to do this part in the SOP solver, but I don't know, it's just a kind of much more challenging method when you start messing around with the actual fields. So what we can do is put this inside a solver node. And I'm going to transfer from and to just the same. So there's two colors. Copy my attribute transfer here, solver. And then I've got my input 1, my input 2, which is my particles. So I'm transferring, and my previous frame, which should show, if I go back to the first frame, the previous frame should show the first input. So it should show just this one. Go inside there. There we go. So solvers are crazy things. They don't usually display very well when you're inside them. So it's always a good idea to jump back out, hit reset, go back in and have a look. So I'm transferring from input 2 to the previous frame. 2 from like that. And this should, let's have a look. There we go. And it errors for some reason. But what you can see is that it accumulates over time rather than hitting and then disappearing. So let's replace that attribute transfer with that. Click through our errors to make them go away and then go back inside here. Probably reset our solver as well. And then hit play. Oh, weird flash of geometry there. Boom. So the explosion is still there, but hopefully what we'll see is that if any holes get created, they will stay and we won't get this flickering effect. And it is. So cool. That's kind of cool. Nice dynamically destroyed mesh. Now the crazy explosion is probably being caused by this. Because we're removing parts of the geometry and removing them very quickly, they're probably registering a rather large velocity change. So let's create a marker, v vector, and have a look. There we go. So if I turn that off, you can see at that point, that's when that hole gets created. And the vectors are jumbo, going out to 250. So that's the problem. We'll just turn that off. We can even register like a 0 velocity by saying v at v equals 0. Or you could also on the trail just set that velocity scale to 0. That would also work. Let's try again. No camera. So velocities. Hey, that looks a bit better. Cool. That's not cool though. So that's our solver needing to be reset. I don't know why it doesn't show up until frame 10. Oh, you know what? Probably the offset that I put in there. All right. Cool. Nice. But the effect could do with some work. So I want it to be a bit more gradual. And now that I've got this solver, it's actually really good because I can do some cool things with this. So the reason that grid is not showing up until frame 10 is because I offset by 10 frames, but my solver only starts from frame 1. So what I would need to do is just say clamp to first, and then it will just clamp to the first frame before that transfer occurs. Now let's make this spreading more gradual. So we got this happening. Let's have a look at the solver. It's pretty strong distance. So let's first go in here and take that down. Okay. Take that right down. And then also, let's make this color 0.1. And it's gonna error. Let me just turn this. Yeah, it's tricky stuff. These kind of loops to visualize this stuff. So at 0.1. Hey, did you? I don't know how to pronounce your name. Sorry, Tushar. Did you ask that in the comments as well? I wrote it down to do a car crash. Yeah, I can definitely look at doing that in the future. I'll have to have a look at the one in Deadpool. This is kind of like the rotating one, right? Yeah, certainly we could look at doing something like that. I'll try and find a cool car model. Let's have a look at this inside the attribute transfer. It might not display correctly. Look out here. Oh, there we go. Error. All right. So, man, this is really tricky. Let me move the solver outside of this whole workflow and disable this. Because this is in the loop with the .NET, it becomes challenging to visualize because it errors whilst I'm trying to figure things out. So if I put it off to the side, then I can run it. This won't be getting deleted, so it's just going to collide with the ground plane now, and now I can sort of visualize this transfer. So now I'm transferring 0.1 red, but what I could do is accumulate instead. So what could I do? So afterwards I could just put an attribute wrangle. Oh, you worked at Mill Film. Cool. Oh, did you add me on LinkedIn? I think I recall that. Haven't really been on my computer this weekend, but cool. Love and Monsters looked great. That's awesome. So I'm going to say at cd dot x times 2. Let's just see what that looks like. Reset. Nothing. Let's do at cd. Oh, times equals. Duh. Alright, still didn't really give me anything. Let's have a look. It may just be my viewport, but I would expect this to be getting brighter. Let me turn off my lights. Let's have a look at our spreadsheet. Times equals, and it's just setting it to 2. This is 0.1. Oh, actually, let's do 1.1. Solvers, so much fun. Let's hide that. Alright, so it's not doing what I hoped, which was to accumulate over time, which is lame. So let me try something else. What I could do is I could say if at cd.x is greater than 0 greater than 0, at cd.x plus equals 0.1. Now what I would hope is that this is going to add 0.1 every single frame that it detects cd.x is over 0. Reset. But it doesn't seem to be working. Geometry spreadsheet. It's just adding it once. I feel like I came across this with a student not that long ago, and I don't recall what the answer was. Let me see. So the color's coming in. See, because the way that I do fading for like wet maps and stuff is to multiply down. So if I just say at CD, oh, you know what? You know what? Maybe. No, I think I'm not setting colors in here, so that shouldn't be an issue. I thought for a second one of the issues is if you like have a color in here, say, and you basically stamp over the color that comes in on the previous frame, then that can be an issue. But I know what's happening. I think. Yeah. What's happening here is that because I'm transferring from these particles onto my grid, is that the area that I want to accumulate in color is underneath where these particles are. And I'm setting these particles to be 0.1 every frame in red. So in here, what's happening is I'm going, yep, I'm increasing them, let's say I do cd.x times 2 times equals 2. So it will increase the value of cd.x on that one solver frame. But then as it loops down, geometry comes in again on the previous frame import, and then it transfers that 0.1 back on. So it's like fighting values. And this always trips me up in solvers. So you have to be very careful that you're not kind of stamping over the thing that you're doing. So I guess one thing that we could do is animate over time, or instead what we could do as well is take maybe our previous frame's information and our transfer and add them together like this. So let's do at cd.x plus equals point. So I'm going to grab the color off the second input. So 0.1 cd at ptnum. And is that all I need to do? Yeah, let's see. Let's see what happens. Reset. Oh yeah, look at that. So we're getting now a gradual addition over time. So that's a really good way to do it, is to kind of, these are the same geometry. So using matching point numbers, they have the same point numbers, so we can take one value from one to the other. But by first transferring it here, this value doesn't change. It's not rising or falling. It's just 0.1 in red. And then adding that to our previous frame, which takes the result of this and then brings it into the next frame. So taking that result and then adding this next frame's worth of color to it. Solvers can be a real, kind of mind bender. But there you go. You can see it works. So now we get this accumulation of value over time. And we could even take this down. So the lower we go with this, the longer it's going to take to accumulate. So let's go. There we go. And what could we do with that? Into our, let's just not use the time shift for a second, into our blast. If if I was to use that blast to delete things, you can see it's happening. So I'm only deleting when the color gets to greater than 0.5. So you can see before that, it doesn't actually get deleted. And then eventually, it starts to erode. So that already is looking pretty cool. Let's run it through. So click out my errors. Oh, crazy errors. Guess we'll go inside here and see if we can force that to recalculate. There we go. All right. This time. Tushar, were you working in Mill Film as an effects artist on Love and Monsters? Come on. You can do it. Oh, yeah. Look at that. We got there in the end. How cool. Sweet. Alright, that's cool. I like that. Nice kind of gradual melting effect. Hey, yeah. I bet you didn't think I was going to get there. There's a bit of fumbling around there in the dark for a while, but yeah, I think, you know, like it does. You definitely want to cache this to disk because it will just kind of yeah, this whole cyclical workflow is very kind of prone to, you know, just error out and flake out because of the way it's kind of working. But there you go. Had faith. I know. You've seen me fumble my way through things for 10 months, Michael. You should know. So yeah, I think that's cool. You know, it's not amazing, but it's a good sort of proof of concept now. And now I can go and make it better, you know. So this red now, maybe we use that before our poly extrude and before our blast, maybe. In here, perhaps, let's just put down a point vault and everything errors. I'm just might bypass this again. There we go. I'm going to put down a turb noise here and I'm going to displace along normal. And I'm going to feed in the displacement amount, turb noise. And I'm going to multiply that by color. There we go. So what could we do? We could do negative, or we could do like a bubbling kind of effect as well, which could be quite interesting. So you can see, you know, as I run that through, what happens as the color increases, that displacement increases because that color value is just increasing over time to the point where it kind of gets deleted. And we could clamp that as well. This color value, because we're adding value every frame, it will be going quite high. In some cases, it could go above 1. So here you go. You can see it's going above 1 there. So we could clamp it. We could put, let's do vector float. We'll grab just the red channel. And we could run it through a fit, or we could just run it through a clamp and just say, yeah, we're just going to clamp all values to 1 or 0.5 or whatever you want. On the displace normal, you also have this scale, so you could always back that off so it never does more. Hey, Robert, how's it going? Happy Monday. So we could do negative, and then we're going to get it going down. So now we can see we're getting that kind of effect happening. We could run this into a fit actually, so that we could get more displacement happening sooner. Let's try that. Okay, it's a little bit hard to see with the red on there, so, you know, it's a good idea to put a facet down after the displace as well. But also a good idea to just get rid of the color, turn my lights back on so I can see it. And it's pretty subtle, but you can see now I've got this kind of, there we go, deformation happening on the surface. Some sort of erosion. So that's cool. Now let's go to our turb noise, maybe add a little more roughness. Play with the frequency maybe. Could animate the frequency over time as well, so that, you know, potentially it just very subtly changes and looks like it's eroding. So there we go. Let's run that into the blast. So now we've got this kind of displacement and then erosion. I'm just going to save this real quick in case it dies. What do we call this? Acid burn. So I might take that scale down a little more. There we go. Look at that. Change my fit, play with that. So this fit will work as a clamp as well, so that, you know, you could clamp it at 1, you could clamp it at 2, whatever you like. So yeah, that might work well. Now these edges are a little bit kind of jaggy, so what you could do after the blast is put a smooth down and turn off unshared, turn off group boundary, and then you'll be able to kind of smooth that hole out a little bit. So you can see that it's a bit nicer. Let's check that. Cool. So let's plug that into our workflow and watch the errors. There they are. Okay, go back in here. See what this looks like. And I mean, you know, this kind of process is not just limited to this effect. You could do all sorts of kind of collision manipulation this way. Through flip, through vellum, through, yeah, whatever. There's all sorts of different things you could do with this technique. So there we go. That's pretty cool. Let's have a look at that. So I'm just going to disable the simulation network cooking so that when I come down here, hopefully it doesn't just break everything. And maybe I'll just do this as well down here. So I can see. A little bit hard to see. Let me put a light in this scene. There we go. It's a bit easier to see the deformation now. And you can see that that noise, the particles are actually interacting with that noise as well. So they're sort of sinking down into that area. And then the hole opens up. Now, this kind of erosion could be driven via a noise as well, so that it's not just completely everywhere all at once. You could drive that via some sort of multiplication over a noise. So again, let's just bypass this section, have a look at what we've got there. So we've got this red, but this red could be multiplied by something. So maybe in here, we take, I mean, we could take the same turbulent noise, but usually just create a different one. Maybe we multiply that against our color that we have here. Maybe coming out of the fit, like that. What if we pump that back into our color output? Then we can see, so what we had in terms of color was this. Now we've got this noisy kind of approach. Take the frequency down, maybe the roughness as well. There we go. If we run that noise into a fit, either here or here, maybe here, you can see I can crush it. And I could also animate these ranges over time. So maybe I'll do that. Let's promote. So you can see as I bring this one down, it creates that interesting kind of erosion effect. But it's also being multiplied against the color. So the color still reveals it. But then what I could do is sort of, as that color is revealing it, also do this kind of thing. So let's just set a keyframe. Okay, 144. Try something like that. Have a look at the blast. You can see now we're just getting these little pockets of erosion. Need to bring this one down as well. So set that one, keyframe. And this one we could go a bit longer, maybe. Don't necessarily need to go the whole way. Do something like that. And we end up with this kind of interesting shape. We've got some unconnected points here. So I'm just going to put a facet, facet, can never remember which one. Unique points, remove degenerate is the one I want there. There we go, gets rid of those unconnected ones. And you can see the smooth creates these interesting shapes. Those ones probably shouldn't be there because they're just sort of floating, but yeah, it's kind of okay. So now we've got this kind of cool effect. Looks a bit more acidy. Plug it into our setup. And watch what happens. Watching simulations is like watching paint dry. Maybe slightly more fun. Let me turn off this guide. It's making it a little hard to see what's going on there. Oh, there we go. It's getting a little pocket opening up there. So this is going to create just a more interesting behavior because it's not just now all dropping in the center. It's sort of really looks like it's eroding that effect over time. So you can imagine this, you know, eating away a structure or something. You could create all sorts of pretty cool, you know, fluid effects, squirting stuff on, you know, some sort of alien squirting something, or I don't know, all sorts of cool stuff. And as you can see, it's starting to look pretty cool. So there we go. Let's have a look down here. And now, you know, putting a... That's right. Some smoke, Adam. Hey, how's it going? Definitely some smoke. We can definitely get that in there. So there's our particle fluid. Let's go and give it a what are we? Green acid. Well, there we go. Toxic Avengers style. Look at that. Beautiful. All right. Good call. Smoke. Let's get that going. Because that shouldn't be too hard, in theory. So I'm going to cache this to disk first of all, because this way of working is, you know, is a little bit kind of prone to error. So put a file cache down. I'm going to call this one flip sim. And while I'm at it, I may just change the resolution a little bit. So let's go 0.05. Oh, our particle separation already was at 0.05, so let's go 0.025. Just see if we can get a little bit more detail out of it. I saw something in a student's work on our CG Spectrum forums just the other day, which I thought was quite cool. They had kind of animated it was syrup pouring on waffles. I can't remember whose work it was now, but it was cool. So what they had done is kind of animated the pour and then stopped it, but then started it again for a little drip. And I thought that looked pretty cool. So I thought, you know, we could try and do something like that. So what you could do there is just go activation on and then off on 25. Oops, 0. And that would then stop that. And then we could just, you know, choose to activate it again for a couple of frames. As if it's a little kind of drip. Something like that. Some sort of monster drool dripping down from the darkness. And then an extra little drip to just splash on top. Could be a bit longer. The duration of that maybe could be just slightly better. Wow, look at that splash that we're getting now with the higher resolution. So, I mean, higher resolution, it doesn't always make it better. It's just, you know, it's one of those things that you can try and just see if you get more details. This is really going to change our look now. I mean, it's going to erode significantly more of that grid. But it might be cool as well, because, you know, just extra sort of detail there. Let's see. Maybe a bit too splashy, but I don't know. Let's just see what kind of happens. Alright, so you can see one thing that's happening here is this stuff that transferred across the surface has actually transferred red. So if we went and had a look at this solver, you can see it has, as it's scooted across the surface there, it has transferred some color. So that aspect of it doesn't quite work so well. So yeah, I guess, you know, you just have to kind of be mindful of the way that you've set things up, and then if you change it, it kind of, you know, could kind of break things slightly. Because you can see they're starting to erode now, and there's not actually any liquid there. So I might just try and calm that down a little bit. Maybe the viscosity could be a little higher. Let's go 100. And then for the last 45 minutes, we'll, well, depending on how long this takes to cache, we'll look at adding some smoke, because that, in theory, should be pretty easy. There we go. Much less splashy now. Maybe too less, but I don't know. It's kind of okay. The solver is still showing the old result though. You can see how it's dipping down in that section, this section here. I think that's from the old solver result. So seeing as we have to recalculate, I might make that 50 so it's kind of somewhere in the middle. Reset. And alright, let's cache this to disk. So I'm going to get rid of the hip name from there. I'm going to do $OS /. There we go. Save to disk. Alright. There we go. Does anyone have any questions or anything about any of this, or just anything in general, or any suggestions for future projects? I'm still collecting, collecting stuff. So if anyone has any more suggestions, I'm writing them down all the time. While that's running, I'm just going to get a quick glass of water and I'll be right back. Flying cow, Audrey. I thought we did one of those. Surely we did one of those. Maybe some sort of melting cow would be good. Cow being melted by alien acid. Yeah, I don't know. There's lots of cool things on this list. Quite a lot of them are really large projects. So yeah, I'm not sure which one to go for yet. I think some sort of pyro, because I haven't really done too much pyro stuff. So, and there've been a few requests for that. Melt that cow, that's right. Well, this workflow would work for kind of any geometry. It doesn't have to be a flat kind of plane. There we go. Oh, no melting, no going through the ground. So what the deuce? What's going on there? Looks like our transfer ain't working. I wonder if it's because of where I put this in the kind of chain, this off to the side here. I wonder if I should put it here. I don't know. Let's reset this and hit play. Oh, there we go. So that's, yeah. I don't know. Reset. Reset. Try again. Luckily, it's not too slow. Nobody's got any other suggestions? I mean, that's cool. You don't have to, but just let me know if you do come up with something. I think, yeah, this is what I have so far. Earthquake, black hole, cool space effect. Could be the same thing. Volcano, planet colliding. There's a lot of space ones, actually. Let's put them in a group. There we go. Volcano could be a good one to look at. Abstract stuff. Yeah, I think that's a good thing to look at, Michael. I think abstract stuff is really fun. Yeah, I really like doing that sort of stuff. Yeah, right. Yeah, well, I mean, we could look at some stuff like that. I like it, Audrey. Making something hairy. Yeah, why not? We can make anything hairy. Glacier carving. Wow. Okay. That's like the collapsing of a glacier front, right? I think that's what that is. We could try that for sure. I mean, that sort of falls into the category of rigid bodies, I guess, and flip. If it is that kind of that where a huge section of ice falls into the sea. Yeah, North Star. I would recommend using Houdini for that type of stuff, definitely. And I have done. Well, I mean, it depends what you want to do. I mean, you can do a lot of those things in Cinema 4D as well, and if that's the kind of software you're comfortable with, then, you know, I mean, it might be worth trying in that. But yeah, I mean, look, for effects, Houdini is best placed to do that kind of stuff. You will get the best results out of it. I don't know what is going on here, but whenever I cache this to disk, I feel like it's kind of interrupting whatever is going on here in my kind of workflow. But that works. And here's my erosion. And let's go into our DOPNet. I guess we can just play it in here and see what happens. Because in theory, no, yeah, I'll turn that off. I don't know what's going on here. Get some wacky things. Yeah, look, I think, you know, Cinema 4D is good. There's lots of cool things that you can do in it. It's more sort of leaning towards the motion graphics side of things, but it depends. Depends what you want, really. If you want like realistic film quality stuff, I'm sure you could do it in Cinema 4D, but it may be, you know, it may be slightly more challenging. But yeah, I mean, if you're comfortable using Cinema, then I would definitely try it first to do it in Cinema, and then, you know, have a look at Houdini though. It's a really good option. But yeah, it's just about, you know, what you're comfortable using, I think. All right, this seems to be working again in here. So something about caching it to disk at the stage that, you know, at the step that I'm caching it, it doesn't like that. I don't know why. Some kind of weird thing with this cyclical workflow. It is a weird workflow, and it does, yeah, it can be really challenging to work with, but as you can see, like as you saw from the start, trying to do it inside here is even more challenging. So I don't know, you're always going to run into issues trying to do this complex kind of dynamic collision solving. I'm hoping that this will fill up my entire play bar here, and then I can just write this result direct to disk. Which isn't great if you had some massive simulation that you had to send to a render farm or something. I would need to kind of figure out why exactly this wasn't writing to disk when I just run it through the file cache. I don't know. It might actually be worth kind of using a different DOP import. It's probably best, maybe, to just create a new DOP import. Ghosting effect like an old TV. How do you mean, Adam? Can you explain it a little more? I mean, I think I understand, but I'm not sure how you would do it in Houdini. Oh no, I lost the tail of my cache. So, all right. Well, let me try doing this. So I'm going to DOP import again over here, just off to the side, and Choose flip fluid. Burst of static and doubling of images. Well, to me that, you know, I wouldn't do that in Houdini, probably. That would be more of a 2D effect. Yeah, I mean, you potentially could do it in Houdini, but an effect like that makes more sense to me to do it in something like Nuke or After Effects, or, you know, because it's a more 2D effect, you can easily create ghosted images in a compositing package, but it might be slightly more challenging to do that in a 3D package. That's not the kind of you know, the what do I want to say? It's not the main thing that the 3D package is meant to be doing. It's, you know, more about creating 3D geometry rather than creating optical image effects. You could certainly do it, I'm sure, but I don't know whether it would be the best use of Houdini, and it would probably take you longer. Yeah. So this is writing to disk again. I'm just going to stop it, just out of curiosity, rather than letting it go the whole way, and see. Whoa. Oh, okay. Zoomed in really far. It's right. It is working this time. So there we go. So just having it not in the chain with all that other junk, I guess, is the way to go. So save that out again. And because that was already stored in memory, it just whipped through those frames, those 90 frames, and it's off and running. I mean, Houdini does have a compositing kind of interface and workflow. In a pinch, it can be really useful. And for doing certain things, it can be really useful if you want to do some texture-based stuff without leaving Houdini. It can be, you know, it can be quite handy. So you could potentially look at doing it in there if you wanted to. But yeah, I think because, you know, ghosting effects and image-based effects, layering, that sort of stuff is just way easier in 2D package than yeah, you know. Northstar, do I have examples of music videos I've worked on? I don't know. It's been a long time. It was a long time ago, and a lot of the stuff that I did actually in these music videos that I worked on was real-time effects. So I used to work for a company doing building projections and real-time 3D and real-time experiences using projectors and object tracking, motion tracking. So the things that I did were more projecting 3D onto something, a building, or like some screens or something behind people. And yeah, so it wasn't really like full-on digital stuff. It was a bit different because of yeah, what I was doing was a little bit different. I'll see if I can find them. It's been a long time, but yeah, if I can find them, I'll show you. Let's have a look. Here we go. So that looks good. Let's plug that into our particle fluid surface, and but to create those 3D elements, I was using Houdini. Yeah, so there we go. So that's kind of cool. Now let's have a look at what we have in terms of our geometry that we could use for creating smoke. So we have this color on here. Let's take this. I'm going to file cache this actually as well, just so that there's no chance that this thing is going to like error out on me and then cause something to break. So I'm going to call this collision geo and write that to disk, and that should go pretty cool. Ah, there we go. Error. Guess So the error's in here. There we go. So annoying. I guess maybe it's the same problem where I'm in the chain and trying to affect it. So maybe I'll do this object merge. What is it complaining about? I think it's throwing an error in here maybe. What a jerk. What? So annoying. Stop import. Reset. Guess if I play it through here, it might work. Again. Come over here. Object merge. Ah. Oh well, I guess I can't cache it out. I don't know. I'll have to look into this and try and figure out why it's doing that. But it's a bit of a pain. Other thing you could do potentially is put this in line here. Set it to write files. And then let's see what happens if I run this .NET, right? Because this .NET is pulling from that geo, but I have now a file cache in line there, which is just passing geometry through. As it passes, it's set to write. So as I step through, it's going to write files to disk. So let's see if when I hit play, it caches that to disk. It's not erroring, so that's good. I'll let it go until it gets to that erosion. I'm running out of time for my smoke simulation here. And then we can flick that to load from disk, and now we can see, there we go, it's written those frames. So that's good, that works. All right, so now in theory, what I could do is go back here, flip sim, save to disk again. And as this one is caching out, it's also going to write out my geometry that's in line, that file cache. I don't know. Let's see. Get a bit sick of caching the same thing out over and over again, but it's a wacky setup, so you got to work these things out. Smoke won't take that long anyway, so it's all right. Well, there's some cool suggestions there. I think yeah, lots of cool stuff. Planet colliding, that's a big kind of effect. Earthquake, that could be a cool bigger project, and volcano maybe. Black hole could be an interesting one. I was at DNEG just after they finished Interstellar actually, and yeah, it was very interesting to read about, and you know, there were lots of talks that they were doing after they'd finished that about how they did certain things, and yeah, it's interesting kind of interesting mathematics that they used on that to create that black hole effect. If you haven't read any of those making ofs that are out there, they're very kind of cool to read how they were looking at light bending around a black hole. I think I want to say Kip Thorne, but I don't know if that's right. I think was the mathematician they worked with, or the astrophysicist or whatever. Cool space effect. Well, that could be any one of these, I guess. I do have a bunch of spaceships that we could look at blowing up. Space debris. That could be kind of rolled into one of those. Achievable laptop effects, I think, is an interesting one to look at. Taking a long time to render, Rizwan. Oh, look, you know, It's only been 2 minutes. It's not that long, really, in the scheme of things. Achievable laptop effects, I think would be a cool one to look at, because that is a question that I get asked a lot, you know, or a lot of students have trouble kind of getting renders out and getting simulations done with the memory that they have, the limitations that they have on their computers. So that could be a good one to look at for sure. Building destruction, it's always fun. Oh, I skipped on. Lighthouse and fog with waves and wind. Very specific, but that's a cool, you know, I think a cool scenario. You could potentially combine those two things together. This one I think would be cool. Underlying skeleton, muscles, and gore effect. I think that could be really good. All right, let's have a look now. And before you do anything, set this to load from disk so it doesn't continue to write and update. And there we go. Nice. Cache to disk. Woohoo. Alrighty. So we've got this color on here. I'm going to run this into a point VOP and crush it. Crush it. Fit. Color. I'll do a vector float into color. Fit. There we go. So I can kind of just isolate a particular color like that. Or, you know, just crush it down to a very specific range of color, and I could use that to drive my smoke. I'm going to scatter points again, and I'll scatter points based on CD. And this will only scatter points where I have that white value. It's jumping around a little bit, so the other alternative is to just scatter points everywhere. Let's see. Scatter points everywhere. I guess the other alternative would be to just delete the geometry and keep the points. And then... Oh, Mitchell. Ouch. That doesn't sound fun. How are you? Can you talk? Lucky this is just chat. So there we go. Just putting an add down, deleting the polygons, and we get points now. The cool thing about this is it's very uniform, you know, it doesn't jump around. The scatter kind of does jump around a little bit. So you can see those points, they kind of flicker a little bit. I don't know, maybe it's not too bad. We can just run with this and see. So, what do I want to do now? I'm going to create an attribute wrangle and say at density equals 1. Nothing fancy. Attribute rasterize, volumetric rasterize, density, massive spheres of volume there, and we got particles here now that are turned into a volume. So this particle scale controls the size of that. And then if we animate this, oh, we can see we got some stuff happening at the start there. That's actually before our color kicks in. So have a look at that. There must be some value there. Or actually, maybe there's just no color at that point or something. I don't know. It's a bit weird. So let's do this. At density equals at cd.x. And then we should see no little blobs until the color actually starts to get created. There we go, cool. Alright, it looks like our simulation starts at 92. Although maybe we want to start it earlier, so we may want to actually just start it kind of at this point when the erosion is starting. Do we have color information there? That is the question. No, we don't. So our color is being passed from that point VOP here, where we added the turb noise multiplying against color. So we don't have the original color in there. Now, probably what I would do is pass that original color into another attribute, and then store that so that I could use it later. But because I don't want to cache this out again, I'm just going to go with what I have, which is this. All right. So let's just run with that. I'll run that into a Pyro solver, just the SOP based one. Set my start frame to 90, 91. And I'm going to go to my sourcing tab. I don't have flame. I don't have temperature field, but I'll pass my density field that I have into temperature. I don't have velocity at the moment. That's okay. Look, I don't have fire. So I'll just turn that off and hit play. Oh, look at that. So the default dissipation is just crazy, crazy high. So take that right down. There we go. So our temperature value is probably a little strong. Let's go back to our sourcing. Turn our scale down. Reset. Reset. Go. It's maybe still a little strong. It's just that one there that's super strong. So I wonder if that color value there, because we're setting density based on color, I wonder if that color value is actually quite high. Oh, it's 1. Whereas maybe the later ones aren't 1. I don't know. That's alright. Doesn't matter. We can turn it down a little more. We could also turn down this acceleration strength, and that might help. Yeah, I don't know. Hey, that's good to hear, Mitchell. Sounds painful on all accounts, getting wisdom teeth removed. I am quite fortunate in that I don't have any wisdom teeth, much to my surprise. So there we go. There's some smoke. Yeah, that one's a bit weird, but, you know, whatever. So let's add some kind of breakup. Solving, shape, turbulence, disturbance. We could also change the buoyancy so that, you know, maybe it didn't rise too much. The other thing we have is this, you know, we've got our geometry here. We can add that in as a collision object. Let's run that into a collision source node. Like this. Merge 2 outputs into 1, because this only has a single input. And collisions is set to create from collision source. So there we go. That's working. Let's hit play. You can see now something interesting happening here. Crazy stuff, because this does have a trail inside it, so it will be generating, boom, crazy velocities. So let's set that to 0. Reset. There we go. So you can see that collision happening there. Sort of. Yeah. It will also help things stick to that collision surface. So the other thing we can do is take our particle fluid surface here and use that as a collider. We could also use this as an emitter as well, but let's just first bring it in as a collider. So I'm going to just merge that with my geo before it goes into the collision source. Might be interesting. Should work. Let's have a look. I might just set the velocity approximation to none. Then it should just pass the velocity from this through, because the velocity on the mesh is okay. So let's have a look at that. You may actually stop it from rising, which might, you know, might be a bit of a problem, but I don't know, it's useful. kind of to have it in there just to see what happens. You can see it is stopping a lot of the stuff rising. Sort of spreading out underneath it. If we combine the fluid with this. Yeah, those two things. Go to the look tab, increase the density so we can see it a bit clearer. You can see it's sort of leaking out under the fluid, which is an interesting effect because what will happen as it continues is that we'll see like more sort of come out as that fluid kind of pulls down. It'll release more of that smoke that's underneath it as these holes open up. So that could be kind of cool. Maybe overall the buoyancy could be a lot greater. I mean, this one is a little crazy, but overall it could be, you know, rising a little more and a little steamier. Let's go to solving simulation buoyancy scale. Could rise that up. Cooling rate, let's set that down to 0.1. And I will up my shape dissipation settings a little bit. Maybe my turbulence as well. So dissipation at 0.15 is removing 15% of the density every frame. So the default of 0.5 is 50%. It's really, really strong. But having a higher dissipation does make it feel a bit more steamy. Low dissipation would be, you know, smoke. But high dissipation is really good for things that are meant to be kind of like steam. So maybe in this case it, you know, it does kind of work well to have a higher dissipation. All right. So yeah, I mean, maybe, you know, maybe we don't need to have that in there necessarily. And then we'll just get kind of smoke coming through the volume or the fluid. It'll just sort of pass through from below. Have you ever lost files? Yes. Yeah, all the time. I mean, you know, I only saved this right at the start, so there's every chance that if this hard crashed without a temp file, I would lose this. So thanks for reminding me to save. Yeah, look, you know, losing files is definitely a part of just, you know, working on the computer in general, and crashes and things happening, things getting corrupted. So yes, absolutely, I've lost days of work because either I forgot to save or I did something bad, and yeah, it happens. It definitely happens, and it sucks when it does. But you know, crashing is definitely a part of working in 3D because you're really pushing the limits of, you know, what you're doing and your computer and the software. So it's just yeah, it's just part of, you know, part of working with this stuff and pushing things. Hey Choho. So, you know, I think this has the bones of a really cool effect, and you could take it and apply it to something interesting, you know, instead of just a flat plane. You could imagine this on a spaceship or something melting through metal, or yeah, I don't know, there's all sorts of things you could do with it. But the collision stuff was the most complex. The fluid, I spent 0 time getting the fluid right. You know, I just turned on viscosity, animated a little bit of emission to get that little drop. And then you can see Pyro, you know, it's only been 10 or 15 minutes, so it, you know, it takes no time at all. But the dynamic collision stuff was the thing. And partly that was just me, you know, figuring it out. But that's the thing that's going to take the most time in this setup, is just getting that stuff right. There you go. Let's see, we've got a nice kind of eroding, melting effect. The shaping of this needs work. It's not really doing kind of that nicer stuff. The dissipation is probably still a little aggressive. It looks, it's really eroding very quickly. So I'll probably go back. Let's go 0, 5. Let's have a look at our turbulence here. So if I turn on that visualization, step forward. I can't remember if this still doesn't work. It didn't. They did fix it, I thought, but there was a while where the visualization didn't work. So control field density. Let me just crack this bad boy open and have a look inside the dot network. Find our turbulence. And where is it? Might be on the pyro solver. Shape, turbulence, visualization. It is on in here, but I'm not seeing anything. You've lost files and had to redo them, Rizwan. Yeah, I feel your pain. I've had the same. It's not fun. It's not fun at all. All right, let's try just increasing this turbulence. Set it to 10. Influence field temperature. Maybe. Control field. We can turn the control field off and just see if we can see any kind of visualization happening. And I think I can. There. And as you can see, it's going bananas now. What happens if I delete this influence field? Nothing. Let's set it to density. Oh yeah, there we go. All right. So I set that to 10, which is really high. Yeah, it is stressful. I guess that's why, it's important to remember to save and to make sure that you're kind of... I save incrementally so that if anything does happen or I make a mistake or something gets corrupted, I have every previous version that I've ever saved, so I could go back and maybe I lost some work that I did, but I haven't lost everything, So I think saving incrementally is a really good way of sort of just keeping a backup of stuff over time. So yeah, the control field doesn't seem to... I can probably jump out of here now. The control field doesn't really seem to be working. Maybe the values aren't quite right. Let's make sure that that's still off inside of here too. Yes, it is. Disturbance as well. Let's go 5. This is super low res as well. Yeah, that's right, Mitchell. Saving incrementally does let you revert. And sometimes like you can be going down some path and it just gets worse and worse and worse. And you don't really know how to get back to when it was good. So you just go, well, I'll just open that file from a couple of hours ago or a couple of days ago when it looked good and start from there and just disregard, like delete. They're all my changes that I had previously done or that I had done since. Definitely, incremental saving. You don't want to just save over the same file all the time. It doesn't give you any kind of anywhere to go, apart from to just try and fiddle around with it to make it better. As you can see with my saving, this is the tornado shot that we were working on a few weeks ago. Tornado Elephant Bonanza 1 through 14. Acid Burn, I'm up to version 1. But yeah, if I, have a look at all these kind of Where are we? Look at that. 47 versions. And you can see multiple times a day I will save this file. Probably not as much as I should, but yeah, there's a lot of versions there of files. Doesn't PayPal have a notification? I don't know what that means. So there we go. It's kind of looking a little bit better. This kind of giant mushroom cloud right at the start's still bothering me, but do you have kangaroos in Australia? Yeah, we do. Of course. We're the only place that has them, right? Unless they're in a zoo. They are native to Australia. I don't see them all the time where I live, but they are around. So there we go. You know, it's looking pretty good. That's right. That's right, Mitchell. I prefer riding a wombat personally. Alright, flipbook new settings. Let's go flipbook this bad boy and start. Oh, you sent me something, Choho. Sorry, I haven't got a notification. But thank you if you did. I'm not really sure where that goes. I assume to the school. Not to me directly through Twitch anyway, because we use Restream, so I'm not looking at Twitch at the moment. I'm looking at just my OBS Restream account. But thank you, I appreciate it. So yeah, I think this is looking really good. Yeah, it's basic. It needs work to make it a feature film effect, but it has the bones of a really nice kind of setup, you know? There's lots of cool things going on here. Now, if this was somebody giving me this, and I was the effects supervisor, these are the things that I would kind of be focusing on in terms of problems that maybe, yeah, you know, there's these islands of things that need to be fixed, that need to be eroded away completely. Maybe the look of the acid itself, the liquid, needs to be worked on. It's a little bit too viscous. But all that stuff is easily changeable with this setup. Yeah, maybe this edge as well. The edge could be something that we could work on and smooth out. Maybe just work on that transition, and this as well. The way this comes on is a little bit kind of awkward and a bit funny. You know, maybe we can just ease that transition a little bit. And timing as well. You know, timing is something that we could work on. But I think this is, you know, I think for 2 hours work, it's pretty good. Pretty happy with, you know, with that. So I hope you guys have enjoyed seeing me kind of figure this one out. And yeah, you know, I think if you ignore all the kind of crazy stuff that I was doing at the start trying to figure this out and just kind of pick up from where I started doing it in SOPs again, then you should be able to follow it through. And if you get stuck or something's not working and you're trying to figure this out, let me know. Let me know in the comments so I can try and explain stuff again. But yeah, it's 12 o'clock. It's time for me to go and have lunch. And thanks for joining me, guys. I really appreciate it. And I hope you're getting something out of the streams, and I hope you're learning something about Houdini. And keep suggesting things in the comments. I'm writing it all down, so please, ask questions or suggest effects, and I'll add it to my growing list. And I will, I will choose these things when I have time to work on a larger project, or I'll start looking for assets for certain things. So, yeah, thanks a lot for joining me. I hope you guys have a good rest of the weekend if you're still in Sunday. Otherwise, have a good week, everybody. And yeah, my name's Daniel Hourigan. I'm the head of effects for CG Spectrum. If you haven't already, please hit like and subscribe, and I'll see you guys next week. Cheers, guys.